Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of Raoult's law. What is Raoult's law? Well, Raoult's law has to do with the fact that whenever you have a pure solvent that has a known vapor pressure at a specific temperature, and you add a non-volatile solute to it, what happens when you add the solute here is that solvent begins to interact with the solute, thereby decreasing the entropy, thereby decreasing the amount of molecules that go from a liquid to a gas phase. In other words, that undergo vaporization. What happens is when you add a non-volatile solute, the vapor pressure will decrease. Okay. There are two formulas associated with this. Both of them require you to remember what a mole fraction is, just in case you forgot. Mole fraction of A is the number of moles of A over the total number of moles present. So here is the formula for the actual pressure. If we're looking for the new pressure that results, you look at the mole fraction of the solvent times the pressure of the pure solvent at that temperature. So again, this would be the pressure we're looking for, what the new pressure has decreased to. This is the mole fraction of the solvent, so that would be solvent over total moles. And then this one is the partial pressure of the pure solvent without anything added to it at that temperature. So when we add this non-volatile solute, again, the pressure is decreased. Sometimes they ask for that new pressure, that last formula we just did. Or sometimes they just want the change in pressure associated with it. So again, the change in pressure uses mole fractions. And what you do is you look at this part right here. The mole fraction of the solute is what is placed in the formula instead of the solvent. So if you find the mole fraction of the solute times the partial pressure of the pure solvent, you would get the change associated with that partial pressure. And then once you get the change, let's say the second part of the question asks what the new pressure is, then you could take the pure solvent pressure minus the change you found to get the actual pressure you're looking for. One last scenario you got to look out for in Raoult's law. Sometimes you're given a volatile solute. So again, non-volatile meant that the solutes do not exert a pressure. So volatile, what do you think that means? It does exert a pressure. So here what we do first is we use Raoult's law to find each individual pressure. Then we use Dalton's law to combine the pressures to find the total pressure. So what does that look like? Well, first part is Dalton's law right here. Total pressure equals individual partial pressures added together. And then the second part is the second part's using Raoult's law twice. We use the mole fraction of the solvent times the pure partial pressure at that temperature, pure solvent. And you do the same thing for the other one. In this case, XA plus XB would equal 1, or chi is what I should say, because it's the fancy X. So that's basically it for Raoult's law. Make sure you check out the examples. There's not much to it. It's more formulas plugging in. Once you understand these basic concepts, you're good to go. Okay. The next concept would be dealing with molality and the associated changes when you place solutes into a solvent like that. That solvent will either decrease its freezing point or increase the boiling point. This is due to the additional IM forces, intermolecular forces that occur between the solvent and the solute, thereby making it harder for things to escape out as a gas, increasing the boiling point, hence a boiling point elevation. And then there's the difficulty of those extra bonds to be frozen, so then it decreases the freezing point, again, due to IM forces. And then you get a freezing point depression. So make sure you check out those videos. I hope I've eliminated any doubts you might have over Raoult's law. Practice, practice, practice. Thank you and have a nice day.